Here's integrated 3, and it's problem 7-113, and it says solve each of the following equations and be sure to check your solutions. So remind me to check my solutions. So to solve this, I would want to eliminate the fractions. So I do my fraction busting. So I think I'm going to multiply the whole darn thing by x times x plus 1. Because that'll get rid of both of those denominators. So I'm going to multiply each of the three terms, the left-hand side and the right-hand side, by this fraction. So when I multiply this fraction by this fraction, these two x's cancel out, and I end up with 3 times x plus 1 for my first term. That's an x. And then when I multiply this second fraction by this, the x plus 1 part cancels out. The x plus 1 part cancels out. And then I get 2x. And then when I multiply this one, well, this ends up just being 5 times x plus 1. So now at least we have everything all, no, we don't have any fractions. And then, I guess we better, it looks like maybe we'll end up having a quadratic or something to solve. So I'm going to distribute my 3. Is that a 1? 3 times 1 is 3. Oh, I hope I don't mess it up. Okay, and then maybe we'll get everything all on the same side. Oh, I should have added these up. So 3x plus 2x is 5x. Oh, hopefully you don't mind if I do that. I'm going to subtract 5x, and I'm going to subtract 5x. Okay, so then I end up with 3 equals 5x squared, because the 5x is canceled out when I did all that. And then yeah, that's right, actually, except for I was supposed to say plus or minus. So this is the answer right here. You can leave it like that, or I noticed that your answer key, they rationalized it. So if I did have square root of 3/5, you can write that as square root of 3 over square root of 5, and then you can rationalize it by multiplying the top and bottom by root 5, and that would give you root 15 over 5. So your answer book shows it like this, and it is proper to rationalize stuff. If you gave me this, I would still be okay with that. Or you can give me this, or you can put it in your calculator, and your calculator will give you plus or minus 0.77. So whichever way, you can give me this, or you can give me this, or you can give me this. Okay, next problem. So the next problem, well, I guess we're going to try to get it all in standard form and see if we can solve it like a quadratic. So basically I'm moving all these terms over to the other side. Okay, and then I'm going to try to do a diamond problem. So I'm trying to think of a number that multiplies to make -4 and adds to make -3. 4 times 1 makes 4. So I think I can write it as x minus 4 Hey, that reminded me, aren't I supposed to check my answers, like by plugging them back in? So let's go back here and make sure. basically with this original equation, the only thing that you really have to watch out for in this situation is just a zero denominator. So I see that either the positive or the negative answer isn't going to give me a zero denominator down there. So I can keep my positive and negative answer. But on this one, I want to check and make sure that there's not going to be a problem with either of these two answers. So when I look at the original equation, plugging these in, there's no zero denominator issue that we have to look at, and I don't see anything where there would be a negative square root or a negative argument of a logarithm or anything. So we can keep these two answers as well. Okay, let's go to the next one. So this one we might want to, when we check, we want to make sure that we don't, like once we get an answer and we check it, we want to make sure there's no negative square roots. Like if we get something and plug it in, it makes it negative, we're going to throw that answer away. So this one we want to solve. So we need to isolate this radical. So what I would do is I don't like the negative sign in front of it. So I think I'm going to add it to both sides. And then I'm going to get everything else over here. So this will be 8 minus x minus 3. Oh, I could get those together. Okay, so 8 minus 3, I guess that's 5. And then now I'm in a position to square both sides. So when I square this side, the square and the square root cancel out, and I just get 9 minus 2x. But when I square this side, I know what you guys are going to do. I already know, and it makes me cry. You guys are going to say that this is 25 minus x squared. And that's not the whole story. This thing, I just want to make a big point about this. That means that it's 5 minus x times 5 minus x. That's what the little squarey thing means. That means you have to multiply 5 times 5 is 25, 5 times negative x, negative 5 times. Basically, it's going to be like 5 minus x and 5 minus x. So you're going to get a 25, you're going to get a negative 5x, you're going to get an x squared, and you're going to get a, this is upside down to me, negative 5x. Yeah, so see how you get two of these? So I can do them in my head. I just square the first thing, and then I take the first thing times the second thing times 2, and then I square the last thing. And that's what we got, isn't it? We got x squared, and then these two made the negative 10x, and there's the 25. Okay, so then we're going to get them all on the same side, so and I'm going to write this in order. I'm going to write this as x squared plus minus 8x, this thing, 25 minus 9 is 16. Something like that. And then I'm going to diamond problem. Is that true? They multiply and they add. Okay. So x equals 4. And let me check that. Now, we want to check it in here and make sure it doesn't make a zero denominator or a zero under our root. So 2 times 4 is 8. So that would make 1. And I can check it and make it sure it's true also. Because yeah, maybe we have something in it and it isn't true. So let's 9 minus 2 times 4 is 8. That's 1. So over here we have 8 minus 1, and then we said x was 4 equals 4 plus 3. Well, that makes 7, and that makes 7. So that's good. So there's the answer to that one.